And so if I set up, let's say, just a box in 3 dimensions to kind of illustrate some relationships. And if I call this line 1, and let's say I call this line 2, and can lines 1 and 2 be contained in the same plane? Yeah, they are coplanar. Okay. When you look at these lines, if they're coplanar lines that never intersect, then you have what are called parallel lines. Okay, so segments and rays and any element, any portion of a line can be parallel as well, as long as that portion falls on a set of lines that are parallel to each other. And what if I put another line down here? Say I call this line 3. Are lines 3 and lines 1 parallel to each other? They're never going to intersect, but are they contained on the same plane? Yeah, once again, we can draw that diagonal plane that cuts across this block. It contains both of them, so those would also be considered parallel lines. Okay, the parallel symbol is a double bar. So if we were labeling the relationships, lines 1 and 2 are parallel. Line 1 and 3 are parallel. Now, what about lines 2 and 3? Are those parallel to each other? Yeah. Any two lines that are parallel to, or two lines parallel to the same line will be parallel to each other. So lines 2 and 3 also parallel to each other. And what if I took and wrote a fourth line right here? Call this line 4. Is line 4 parallel to line 2? No. Is line 4 coplanar with line 2? Yeah. So it's possible for coplanar lines to either intersect or not intersect. If they don't intersect, they're called parallel lines. If they do intersect, they're just referred to as intersecting lines. Okay. But what about lines 4 and 1? Are those parallel to each other? No. But do they ever intersect? They're never going to intersect. Can you contain them in one common plane? No. So if something is non-coplanar, if it's never going to intersect and it can't be contained in the same plane, then it's called skew. Okay, so lines 1 and 4 are referred to as skew. And skew just means non-coplanar lines, or skew lines or non-coplanar lines. Chris? Well, again, you think of it as my arm is line 4, and then this arm is line 1. And if you extend them, yeah, it's behind with the depth of that box. Monica, is that your question also? Okay, again, this obviously only exists in the 3-dimensional space, the relationship. Right, now, there's a couple things regarding slopes of lines that are parallel to each other. When you're looking at a set of coordinates, and you have one line, let's say, has a slope where our rise of 2 and our run of 3 lead you to 2 separate points. If we have a second line that's going to be parallel to that, what will its rise and run also have to be? 2 and 3. That's the only way for them not to intersect each other. So when you're looking at parallel lines, the slopes of parallel lines have to be equal. So if I say that line 1 has a slope of a over b, what does that mean line 2 slope is? A over b, and line 3 has a slope of a over b. All those parallel lines would have the same slopes. Okay, now, as soon as you create what we just constructed, which were perpendiculars, okay, when you're dealing with perpendiculars, does anybody know the way that the slopes have to relate when lines are perpendicular. They are, so we have the same. Our rise of one becomes the run of the other, and the run of the one becomes the rise of the other, but in the opposite direction. Okay, so the slopes of parallel lines are equal, and the slopes of perpendicular lines are negative reciprocals. Okay, so that means if the slope of this given line is 2/3, the parallel line will have a slope also of 2/3, but the slope of a perpendicular line will be negative. So we switch the sign, and then we also flip or invert the fraction. So it becomes 3/2. So looking at this example over here, what would the slope of this green line 4 have to be if it meets at this right angle on the edge of the block? Negative b/a. Okay, so you just flip the fraction, change the